Hello, and welcome to the OWASP Tampa chapter talk on care and feeding of programmers addressing application security gaps using HTTP headers. Some information about myself. I am an information security architect, and I am also an author of the Secure Coding Field Manual available on Amazon. I do education, mentoring, as well as consulting, and you can contact me at my Twitter account. Now, if you recall, back in 2013, there was a celebrity photo hack against the Apple iCloud, and there ended up being some naked celebrity photos that were placed on the internet due to the attack. Now, the attack was actually attributed to a few things. This article points out that there was an injection of a malicious script. We also know that there was some brute forcing done to passwords for these people's accounts. The interesting thing that I want to focus on in regards to this talk is the injection of that malicious script. Now, we know that there are certain settings, particularly for a web server, should protect users against the injection of malicious scripts from foreign sites. Let's look at what this particular policy is called. So this is known as the same origin policy. So what is it exactly? It's a web application security model that is built into all of the modern browsers. What it's supposed to do is constrain any kind of resources to be restricted to the origin. Now, that origin is set by the protocol, the port, and the host name. I have some examples here where if the origin is set to be http store.company.com, then anything following directory-wise will be fine to go ahead and execute or be forwarded to. And if you look at the next example, that directory structure would be fine as well. Now, the third line shows a failure because we have a change in the protocol. We've gone from HTTP to HTTPS. The next line fails because we have a change in the port number. We've gone from port 80 to now port 81. And then, of course, the last is a failure because it has actually changed the host name. So we've gone from the store.company.com to news.company.com. So what exactly does the same origin policy protect? Well, it's supposed to protect foreign requests from executing in an authenticated user session as long as that foreign request is coming from a different domain, right? As long as it violates one of those three principles that we set for the origin. So, for example, if a user is logged into https://mybank.com, they open a tab to a vulnerable site that happens to have a planted cross-site scripting attack there. And that cross-site scripting then attempts to inject a malicious iframe into the user's authenticated session on their other tab for mybank.com. SOP is going to stop that attempt, and the reason is because it's a different host name, it's a different protocol, etc. if it's trying to do it over HTTP, etc. Now, where this policy usually comes into play is there is a breakdown between, sometimes there can be a breakdown between the setting of the policy and the developer's code. So if you have system administrators that set up a web server, they might go ahead and set a header called xframe. And if they don't actually set the value, chances are the default value is going to be same origin. And that's where we get this same origin policy. The thing is, a lot of developers don't even realize that this is a header or what it does. Or what it's meant to protect. Now, if there is no need to allow for the reading of any foreign resources, whether they be pages or images, etc., we should set this to deny. If there has to be explicit domains to be incorporated, which is commonly done, if you have images and you want to import them from one site into another, you can actually have an explicit allow from. Now, this X-frame header option is going to protect against the clickjacking attack. That's what we saw when we described our example previously of the mybank.com. So same origin policy will protect from that. However, it will not protect against any externally referenced images, style sheets, or JavaScripts. So, and this is a misnomer because a lot of people don't realize this. The reason why external scripts or images or style sheets are allowed by SOP is because SOP doesn't view these components as data. And so by default, they're going to allow access of these foreign sites into your web page as well as the execution of them. Now, why is this a problem? It's a problem because it allows for attack vectors. In extreme cases where there's also incorporation of something called JSON padding, which you can hear more about from the Black Hat European talk in 2014 by Ben Hayak. Basically, he describes this bypassing of the same origin policy to provide the ability to implement any operation on the user's behalf, which is pretty scary. Now, in his talk, he goes into the use of something called callbacks, and callbacks are legitimately used even today by many companies so that you can import information from one website into another. So if you wanted to import, say, your Yahoo contact list into your Google Gmail account, the ability of doing that has to be done across different domains, and so these callbacks are used to do that. Unfortunately, if they're done on the client side, they can very easily become injection points for attackers that can then insert their own malicious callbacks and end up controlling your account. So let's talk about defenses and countermeasures to these types of attacks. The first thing I want to talk about is the content security policy and a lot of the secure HTTP headers that are incorporated in it, and then we'll discuss HTML5 whitelisting. So what exactly is content security policy? It's a whitelist that you can define in your web application to authorize the execution of scripts. Content security policy is going to provide you with a depth of directives to fine-tune or fine-grain policies so that you can have a lot more control over what actually gets executed in your web application. Now, the way that the policy is delivered is through an HTTP header. I'm going to show you how you can do that either programmatically inside of your code or configured in your web server. And as I mentioned, there is this explicit whitelisting, and we'll go through that. You can think of the content security policy as kind of like a poor man's version of a WAF, because it helps to sort of address the low-hanging fruit in regards to injection-related attacks. Now, as a programmer, why should you care about this? Because it really can be an effective measure to cross-site scripting attacks. And of course, a lot of cross-site scripting attacks can lead to CSRF attacks as well. It can protect your DOM in instances where that DOM is is trying to be referenced externally, which of course means that you're protecting any data leakage and AJAX attacks. Now, it will protect against externally referenced images, styles, and scripts going beyond what SOP does not do for you. I will caveat that though with in regards to the callbacks and the JSON P, that is another dimension of attack vector that actually requires a little bit more validation. But for the bulk of what we're trying to address here, content security policy will help to mitigate these types of attacks. To see a quick example of how content security policy is set, you can see the header here, content security policy. So you would basically use in your response object the set header method to set the name of the header and then the value for that name. In this instance, the script source, which is a directive, is going to have the value of self. This means that for this particular policy, only content from this website is going to be allowed to execute, and that's going to include any externally referenced images, style sheets, and scripts. Now, there are a lot of cost efficiencies that are gained by using content security policy. It can obviously protect your entire web application and all of its subdomains if the policy is set at the right level. And this is really important because a lot of times programmers, even though with their best intentions, there are going to be areas or pockets of their web application that they miss for cross-site scripting, or maybe they haven't completely validated every area or output encoded each context, which is something that can certainly happen. And so content security policy helps to sort of put a blanket around that low-hanging fruit. It also helps in mitigation techniques and development cycles that usually have to be churned when addressing pen test results and fixes and static code analysis fixes. Now, as I mentioned earlier, there are two ways to implement content security policy. You can either do it at the web server level or you can do it programmatically. I'm showing here IIS configuration and Apache's configuration, and then programmatically. So for Java, this is one example. Also, you could use the response object dot add header, and then you name the header and then give the value that you'd like. Now, there are a lot of directives that are available in the content security policy. I'm just highlighting a few here, but you can see as you look at the names, you've got a default source, a script source, an object source, a style source, an image source, a frame source, even a reflected cross-site scripting policy where you instruct a user agent to activate or deactivate based on some filter. So this is where we get into the fine grain or the fine tuning of the policy to be specific to your web application. There could be instances where you need externally referenced sources. And so CSP allows you the ability to actually add that in.